Hello. I want to tell you today about the first of Sir Isaac Newton's 3 laws of motion. The first law, as we remember it, is that an object at rest tends to remain at rest unless acted upon by an external force, and an object in constant motion tends to remain in constant motion unless acted upon by an external force. Now, as you sit calmly in your chair there, you probably think of yourself as an object at rest. Gravity is pulling down, the chair is supporting you, it's pushing up, you're in a state of equilibrium. But if the chair wasn't there, or it suddenly lost its ability to support you, you would again regain an appreciation that you are under the influence of the Earth's gravity. Your mass and its mass are attracted toward each other. But let's talk about the part of the law of motion that is that has to do with either at rest or that statement about being in constant motion. Well, again, you think of yourself being at rest, but is that entirely true? And so I'd like for you to think about 2 different perspectives. We'll call them 2 different frames of reference. Right now, your frame of reference is, of course, the building, the floor. The floor is attached to the building is attached to the earth, and if you look outside, we are not moving. But again, the earth is a sphere, a planet that is revolving around the sun. And also, we can appreciate that this planet is rotating or spinning on its axis. And we need to think about that for a second, because it turns out that where you sit is about 4,000 miles from the center of the Earth. And if we think about the circumference or the distance around the Earth, well, we know that that's about 2 pi r. That turns out to be about 24,000 miles. And that should ring a bell, because you also know that it takes about 24 hours for the Earth to make that one rotation. So if we remember back that speed is the ratio of distance to time, pretty quickly we realize that 24,000 miles divided by 24 hours, that's about 1,000 miles per hour speed. That's right. As you sit in that chair, you are traveling eastward from this room at about 1,000 miles per hour. And you know that's true because the sun is going to appear to move westward in the sky. But now, Newton said that, suddenly I feel a little unsettled. I'm traveling at 1,000 miles per hour here. Newton told us that because of our masses, we can think of our bodies as having a certain amount of inertia. So I posed the question, what would happen if the Earth suddenly stopped? The Earth stopped spinning in a very instantaneous, abrupt fashion. What would happen to this building, this floor, the desks, the chairs, and us? Well, because of our inertia and our tendency to keep moving at a constant speed, even though the earth has stopped, we would travel that direction at 1,000 miles per hour. And that would not be good. So I hope that you appreciate that in the frame of reference of our school building, you are at rest. But in the frame of reference of someone that is maybe in space looking down, we are all, everything that we see, us included, around, is all traveling at about 1,000 miles per hour. In any case, we will continue in that constant motion or at rest until an external force acts upon us. The last thing I'd like to mention about this discussion is if we could open up a freeway right down the middle of the ballpark in Arlington, we could drive our pickup truck at about 92 miles per hour. And of course we'd want to have our safety gear on, our helmet and whatever. But if we took a baseball, piece of paper, this is going to substitute for a baseball. And as we're driving, we drop that baseball right just as we cross the pitcher's mound. Bang. That ball, with us traveling about 90, is a respectable fastball, and it would travel a path very similar to what a professional American Baseball League pitcher how he would deliver a fastball from that mound to his catcher. So you should think about that and how things truly are. If they're in motion, that motion is relative to other things. So thank you.